a quick video to show you how we deal with it when we have, instead of a hyperbola in its normal form, where we have x minus something or x plus something down the bottom here, we have something minus x. Doesn't seem like much of a change, and it's not, but it does make some sort of difference. We will also look at truncuses to see what sort of difference it makes in a truncus as well. So the key thing here when we're looking at a hyperbola over here is it's still pretty clear that x is not allowed to be 3. So just like if we had x minus 3, we'd be dividing by 0. If we set x equal to 3, the same would be true here. So that means just like if we had 6 over x minus 3, we're going to have an asymptote at x equals 3. And once again, just like if it said x minus 3 here, there's nothing that can make this thing here 0, which means f is never going to be equal to exactly 2. It's always going to be 2.01 or something. So asymptotes actually end up being in the exact same place as if our function was y equals 6 over x minus 3 plus 2. So at the moment, so far, it doesn't seem like this negative sign is doing anything at all, or at least this way of writing it. One way to get at it though would be to factor out a negative 1 from the bottom here. So just to write this denominator as 6 outside of negative 1 times negative 3 plus x plus 2. So see that if I multiply this negative 1 back through, I just get 3 and negative x. So this is unchanged. It's just a different way of writing this. But if we go now 6 divided by negative 1, we're going to get negative 6 on the top here, and we're going to get x minus 3 on the bottom. So notice the effect of this negative sign here is actually to basically put a negative sign on the top here. So this is really just the same as this, but with a negative sign in front of that 6. And what effect does a negative sign have on a hyperbola? Well, it means instead of having a graph that looks like this, like a normal hyperbola, we actually get a reflection. Sorry, so it looks like that instead. So let me sketch that in. So we end up with something that looks like this. So the negative sign ends up just reflecting our hyperbola. But what's interesting is when we do the same thing with the truncus, we're actually going to find something very different. So let's try and do the same thing again here, but notice we've got brackets and a square here. So when we pull out the negative 1, it's still going to be sitting inside this square. So let's just do that. So notice when we do this pulling out of the negative 1 times x gives us our negative x, negative 1 times negative 6 gives us our positive x. I've just reversed the order here, but you can just think of this as negative 6 plus x if you like. But this negative 1 is still sitting here, but it's inside the brackets being squared. So we could then evaluate this. We could square both of these terms here inside the brackets, and we end up with negative 3. The negative 1 squared is just positive 1, and so this just becomes x minus 6 all squared plus 12. It's as if this was just written x minus 6 from the start. There's no change at all due to that. So what that means is we can just sketch it as we would as if these two were reversed, and that's just a standard truncus. So let's quickly do that. The vertical asymptote is going to be x equals 6. We've got a negative sign on the top, so that means we're down in the lower half here, and we can just sketch that in. Make it a little bit steeper than the hyperbola below. Trying to keep it as symmetric as possible, but it is pretty hard. And we're done. So what difference does writing something minus x make? For a hyperbola, it reflects it in this direction. For a truncus, it has no effect at all.